Hello, my name is Drew, and I'm a mathematics tutor here on Wyzant. I tutor a number of topics, but today we're going to be talking about Hessian matrix, calculus, linear algebra stuff. So the poster says here that we are given a 3 by 3 Hessian matrix. They want to know how to solve for the determinant and identify if this is a saddle point or a maxima or minima. So I assume that this question is asking just generally, given some Hessian matrix, how do we identify saddle points, minima, maxima, etc. Now, and they asked, they said something about the determinant, which I believe you could probably invoke in this case. So let us first kind of point out that this is having to do with something called the second partial derivative test, which is used to determine whether a critical point is minima, maxima, saddle point, etc. And this kind of harkens back to like your Calc 1 class where you had functions in one variable and you found your critical points and you wanted to determine whether they were maxima or minima and what have you. Or saddle points, you would find the second derivative, and whether or not it was positive or negative would tell you whether it was a maximum or minima or what have you. And this is actually no different, really. It's the same kind of idea here. So using this Hessian matrix, which has the second partial derivatives of some multivariable function, then you can determine whether some critical points that are given, I'm assuming that you found the critical points already, determine whether or not they're maximum, minima, etc. So first I'll use the 2 by 2 example here just to show you something here. So in a 2 by 2 matrix, say we have some 2 by 2 Hessian here, what we need to do here is, and the reason that you find the determinant here, the Hessian determinant of this matrix, is because if the test goes, if the determinant of this Hessian is greater than 0, then that point that you are trying to find, assuming that of course you plug that in, if it's greater than 0, then that point is either going to be a maximum or it's a minimum, one or the other, right? Now, if the determinant of that same matrix is less than 0, then that tells you there is a saddle point. And the reason this works is for a very important reason. So this reason is that the determinant of some matrix is actually equal to the product of that matrix's eigenvalues. So in this case, for a 2 by 2 matrix, if the determinant is greater than 0, that tells us that the eigenvalues are either both positive or both negative. So that tells us that it's either maximum or minimum. So if both eigenvalues are positive, then it is positive definite. If they're both negative, then it's negative definite. And that tells you whether it's a maximum or minimum. If the determinant of that 2 by 2 matrix is less than 0, that tells you that one is positive and one is negative, which means that this is a saddle point here. So this is why this test works really well, because you can determine, whether or not it's an extremum or if it's a saddle. Now, in the case of the Hessian matrix that we're given here, it's a 3 by 3 matrix. This test still might give you some insight in there in terms of determining whether or not it's, but it's not going to be a foolproof way. And the reason is this: if you add a third eigenvalue in there, which it would do if it's a 3 by 3 matrix, then if it's positive, that tells you that either they're all positive, which would be a minimum, or it tells you that 2 of them are negative and one's positive, which would be a saddle point. Same thing, if they're negative, that tells you that they're all negative, or that 2 of them are positive and 1's negative. So, so you can gain some vague insight, but it's not going to really tell you anything precise. So what I would suggest in this particular case is to actually find the actual eigenvalues in this case. So to find the actual eigenvalues at those points and see if they're positive or negative. If you have all of the eigenvalues are positive, then it's a minimum. If all the eigenvalues are negative, then it's a maximum. And if there are mixed, if there are positive and negative eigenvalues, then that tells you that this is a saddle point. So in terms of the process of actually finding these eigenvalues, you should remember how to do that from, your basic kind of matrix manipulation, finding eigenvalues of matrices. If you need more help with that, I'm happy to help you. You can schedule a session with me at any time, but hope this helps.